Hello, everybody. So I'd like to discuss a little bit about what's going on in Telecom infrastructure project, some of the structures, but also what Facebook is doing in general. Let me start with this. So last year, Facebook set out a 10-year roadmap that entailed very, very important systems, ecosystems, products, and very relevant technologies in the future that we try to focus on. Today, I will talk about some of those, especially relative to the infrastructure project and the telecom infrastructure. We see as Facebook, and I think so see many other data center providers, that we actually started off with very few traffic demands like 10 years ago. We basically allowed at Facebook just to text a couple of bytes. That in the next phase, we allowed to post photos, megabytes. And the next phase, we allowed to post videos. So you can see the quality of posting is just increasing drastically. And now we move into the world of immersed experience, VR and AR. And you probably heard a lot of these things over the last days, and there's a lot of press releases out there. And you can imagine that this also will boost the need for storage, compute, and bandwidth. In general, though, there's more factors that are important from networking perspective. There's also the frequency of postings that is also increasing. That means not just that more people post, but also the frequency was increasing over the last decade. So what does it really mean for us as Facebook? It means we need to provide the infrastructure, some of the infrastructure behind it. And of course, predominantly we are building, as you can see, some data centers. And here are the 9 announced data center sites. Just to give you a little bit perspective, one of those data center buildings is as long as the Empire State Building is high. So these are fairly large buildings, and these sites typically do not just have one building, but several. So behind that is a lot of tech, a lot of infrastructure, compute, storage, that needs to be built. And so you can imagine that those infrastructure needs to be also somewhat distributed across the globe. And what you see here is essentially the locations, and you can see it is a global infrastructure. So where is the community that we serve located? Let's start maybe a little bit differently before we go into this aspect. Let's have a look at where is the connection. And so this is the picture of the 2G, 3G, and 4G connection that we see. And you can see there are massive black spots. I think that's the first visible thing. Like in big parts of the world, it's actually not visible. So people don't have access to internet. And so that means you can see that we see what we see, right? What we have ahead of us, because we can see people of internet. But how do we actually figure out how we actually know where the people are that don't have access to internet? And that's where it becomes tricky, and especially when you think about how important internet access is to build communities all over the world of different sizes, and how people live together and actually want to build an effective culture and economy that really requires a fundamental communication with each other. So we looked at that problem. So we tried to understand, are there any population density maps around? And we figured out that actually the granularity so far, here an example from Naivasha, Kenya, is actually, you can see on the left side, a typical satellite image, and on the right side, images of population densities. So we looked at ways how we can actually use our AI division and AI knowledge to actually retrieve from those satellite images population density maps and found those population density maps to be extremely useful to identify where people live and where there is actually connectivity and where's missing connectivity. So we believe that actually some 4 billion people out of roundly 7 actually do not have internet connections for various reasons. Of course, not just one reason of availability, it's also awareness and affordability. So to connect the world, there is no single silver bullet. It really requires a huge ecosystem and several technologies to make that work and happening. And that's also one of the motivations for us to build communities and open communities in technology to really achieve that. But let's go a little bit a step back and have a look at what are those technologies that we are actually trying to drive right now. So first of all, clearly, fiber for point-to-point high bandwidth is the most effective technology. But we also look at wireless technologies, like predominantly in the millimeter wave spectrum. Here are some examples from MIMO or our UAV examples that we made public, or Teragraph. So you can see there's a variety of technologies we're looking at right now that allows us to drive this connectivity paradigm into application spaces that were, we believe, mostly neglected in the last years or decades. So one of the initiatives, and I mentioned before fiber is one of the most effective one, is our Uganda project. It consists of approximately 770-kilometer fiber build in the northwest of Uganda. And it's a collaborative effort with Airtel and also other providers to really allow an effective backhaul system in Uganda to connect millions, and we believe 3 million people altogether. This is just one example of how, and we look, of course, in the future into other examples, how we actually can, in a targeted way, with targeted investment, drive connectivity to many, many more people. So we actually have announced several projects over the last 12 months, and I cannot cover all of those. I only have 20 minutes. But I'd like to show a couple of those also in the next slides. But I'd like to emphasize one of those is the Telecom infrastructure project that actually was started only last year, February 2016. And in the meantime, we have announced several of other activities like things like open routing, or we have looked at and during Mobile World Congress, we made a couple of announcements. So please look at our blogs. But I like to emphasize, though, two communities we try to help building. One is the OCP community, Open Compute Project community, and the other one is the Telecom infrastructure project. The OCP is a very active community, and I just wanted to show you over the years since existence in 2011 how many submissions just from Facebook were made, mostly around, of course, compute storage and networking. And just this year, we did some what we believe major announcements. So these are all, in the end of the day, white box for computer, storage, and networking. A very vibrant community for data centers. So the Telecom infrastructure project, and I mentioned before, was founded last year, February. So it's more than a year old, but has already more than 450 members. And some of those major members, are just listed here for illustration purposes. So it's really amazing how quickly these membership grow, and also how it's been structured. Essentially, there are 3 big areas that are being addressed in telecom infrastructure. That's the access, backhaul, and core management. And there's leadership appointed and working groups being built. And I think I will talk about a few of those right now and how we actually make this whole TIP ecosystem work. So one of those topics I will touch on is the open optical packet transport that I'm co-chairing together with the CTO of Equinix, Ihab Terazi, and we talk about people and processes. So first of all, and you probably heard it today in some of the talks, transforming an industry is not just a tech issue, it's also for sure, and maybe predominantly, a people and processes issue. So many of the operators in TIP actually had the idea to found this TIP People and Process Group that really deals with many aspects of change and how network operators can deal and should deal with it. So clearly behind that is how can we accelerate deployments, new deployments, how can we get into the new DevOps world, how can we transition to other operating models. So many of these essential questions are actually people and processes questions, not just a tech question. So there are many work streams, 4 of those, dealing exactly with things like diversity, culture and talent, and fundamentals of how you build, from a people and process perspective, your infrastructure and DevOps areas. But that's one aspect and one angle. The other angle is how can we actually make the entire TIP innovation globally work. And one of the ideas is actually the idea of a TIP ecosystem acceleration center. So we are working with this global community of operators to really expand the idea of bringing finance startups together with the operators to actually build something new, and really having this entrepreneurial spirit in this TIP organization. And the idea really comes out of the status quo where we are today, because we see a lot of vendors in the telecom space innovating for a long time, and that's fairly expensive, missing essential VC funding, and startups are not being formed, even though ideas are around, and that leads to stagnation. We actually believe we can reverse that stagnation. So, so far, there are 3 TIP ecosystem acceleration centers in the world. SK Telecom in Seoul, BT in UK, Orange in Paris are the lead operators for those. And we believe there will be a lot more in the future. Having said that, I'd like to give an example for one of the TIAC centers in the UK. There were leading VCs, university, private, public funding entities coming together to actually, raise up to $170 million of funding for that purpose of driving innovation for telecom infrastructure. Let me go back to tech. Many of these questions that all of those entrepreneurs are actually addressing have to do with a fundamental question of how you actually consume technology and innovation. Essentially, from a very monolithic, and actually deliberately put a black box here, to a disaggregated but also integrated system that allows modularity, flexibility, and best-in-class. A life cycle that is for sure better, we believe, and an ecosystem and an openness behavior that allows to really cycle out and in new tech. So this is a fundamental question that comes up and down in one or the other way. Clearly, an example for that is when you actually disaggregate would be a clean separation between software and hardware. It's just one example what that actually can allow you. We have tried to figure that out for so many areas as an industry, but we believe it's now time to have a fresh look at that. And the Open Optical Packet Transport Group, working group, is actually looking at disaggregating the switching, routing, and transport for hardware and software from many perspectives. And there is, to be honest with you, no clear and easy answer. When you look at the complexity and the number of components you want to disaggregate, you don't want to disaggregate too much, and you don't want to disaggregate too little. At the same time, it's a moving problem that changes in time. So we set ourselves out the target to really figure out what it means to disaggregate, and came up with some examples and trials to really get our arms around it. So how do we do that? First of all, in this working group, we look at contributors, just people who build, engineers, have ideas. The idea is, of course, you can't work with each other when you don't open source it. We look at system integrators and operators who actually lend that gear in their production. So for that, we actually tried to segment the problem into, it's a packet optical transport after all, right, into a line system, amplifier line system for DWM, into a transponder group. And we looked at, hey, this is a technology, this is in disaggregation. There's a transponder and there's a line system. Why don't we form two groups? One dealing with the transponder, and one dealing with the open line system. And then, wow, there's so many reasons why you wouldn't do that. So we decided we actually build a physical layer system simulation environment around it so that there is, in future, no excuse not to do it, so that we can actually plan for it. In addition, what's important to us is the common API aspect that essentially also helps us integrating all these pieces together. So we have essentially formed 4 working groups that are up and running, leadership defined, and is steered by an operator council. So the operators are giving use cases, approving submissions, and also helping guaranteeing that the quality that is delivered is okay and useful. To start that group, and last year in one of the keynotes I actually announced that we look at that, we actually looked at building a white box for transport, switching and routing, and we announced that in November. That's Voyager. So we believe that's actually the first white box for that domain. It's essentially a 4 times 200 gig DWM long haul transponder with up to 12 times 100 gig client interfaces. We have built the first box to the first field trial within 6 months. So by using available technology and technology that is also used in high scalable data center environments. And here is an example from where Wedge is our top of rack switch, how we actually use that to transform it into a Voyager DWM packet optical transport system. So we had several field trials and about to have several field trials. Here are the labels of the companies. And let me just give you a couple of examples and findings of those field trials with the use of this transponder Voyager. Telia did one long-haul field trial and essentially was very highly complementing the operational and installation experience and the fastness of how fast the installation. That's actually very relevant from an operational perspective. You heard today, one of the key design parameters for us is to make things scalable, fast, and operational simple. So this we consider this as a complement for TIP and this approach. And Equinix, Ihab Terazi announced that essentially he sees big cost savings for him in Equinix using this type of approach and technology. So essentially, this talk described some of the activities we are doing in Facebook. This can't be ever complete. You've seen there's a lot of many more projects with many great partners. And I think what I tried to focus on was on some of the few fiber-based projects and culture processes, but also how we try to figure out how we build a wider ecosystem of finance, entrepreneurs, startups, operators moving forward. And you can imagine connecting the unconnected in the world takes all of us. It's not just a simple thing, or just making internet even better in this world, in this place here, takes a lot of efforts. It's not just done by one company. It's really here an open invitation to innovate and build something new. Thank you very much.
Thanks a lot.